In this video, we will study probability distribution, and to understand probability distribution, we must know what is a random variable. In probability, the outcome of an experiment can either be a number or not a number. And when it is not a number, we use a variable to denote its numerical value. And this variable is what we called a random variable, or in short RV. Random variable is a function that assigns a real number value to the outcome of an experiment. Random variable is denoted by capital X, and a particular value of random variable x is denoted by small x. In an experiment of tossing a coin, random variable x assigns value 1 to head h and value 0 to tail t. Thus, x is a random value function x from the sample space S to the set of real numbers R. Just like any other function, random variable x must be a single valued function, which means for every sample point S of sample space S, there corresponds exactly one value of random variable x. Therefore, it is always appropriate to write probability of random variable x greater than or equal to 12 rather than to write probability of small x greater than or equal to 12. Whatever we have discussed so far, let us understand through specific situations. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. Random variables are of two types: discrete and continuous random variable. To understand discrete random variable, we will consider an experiment of tossing a fair coin. The sample space S will have two sample points h and t. Let x be the random variable that denotes number of heads h. Then we write x of h equals 1 because we have to consider number of heads, which is 1 in this case, and x of t equals 0 because we do not consider number of tails. In another experiment, if two fair coins are tossed, then the sample points in the sample space S will be HH, HT, TT, and TH. Now let x be the random variable that denotes number of tails as the outcome. Then we have x of h, h equals 0 because we do not consider heads. X of h, t will be 1 because we consider tail only, and there is one tail here. X of t, h will be again 1 because we have to consider only tails, and there is one tail here. And finally, x of t, t will be 2 because we have to consider tails, and there are two tails here. In above two experiments, x takes finite or countable numerical values such as 0, 1, 1, 2, etc. Hence, x is called discrete random variable. Now we will see what is a continuous random variable. Suppose random variable x denotes arrival of a train between 10 a.m. and 10:15 a.m. Then it can arrive at any moment between 10 a.m. and 10:15 a.m. Here x can take any numerical value uncountably infinite between 10 a.m. and 10:15 a.m. In this case, random variable x is said to be continuous random variable. we will see probability distribution of a discrete random variable. Let x1, x2, x3, so on and so forth, xn be the discrete values of random variable x, and p of x1, p of x2, p of x3, so on and so forth, p of xn be their corresponding probabilities. We denote these probability numbers by pxi, where I is 1, 2, 3, so on and so forth n, must satisfy following two conditions. Number 1, p of xi should be positive or 0 for all i's, and number 2, summation of p of xi, where I runs from 1 to n, should be 1. Here p is called probability mass function, or PMF, or probability density function, PDF. The set of pairs of xi, which is the value of the random variable x, and p of xi, which is its corresponding probability, is called probability distribution. In the first example, we will find probability distribution of number of heads h, which is the random variable x, obtained when a fair coin is tossed 3 times. When a fair coin is tossed 3 times, or 3 coins are tossed once simultaneously. In both these cases, number of outcomes will be 2 cube, where 3 stands for number of times the coin is tossed, which is 8, and the list of the outcomes will be triple H, HHT, HTH, THH, triple T, TTH, THT, and finally HTT. Total 8 outcomes. Let us write the probability distribution in a tabular form, where random variable x is 0 heads, and corresponding probability of random variable x equals small x is number of 0 heads is occurring 1 times upon total number of outcomes 8. So 1 by 8 is the probability of random variable 0 heads. Next, for 1 head, we have these 3 outcomes upon total number of outcomes. So 3 by 8 is the probability of 1 head. For 2 heads, we have these 3 outcomes upon total number of outcomes 8. So 3 by 8 is the probability of 2 heads. And finally, for 3 heads, we have just one outcome here. So its probability will be 1 upon total number of outcomes 8, that is 1 by 8. So this is the probability distribution of x. We confirm that this is probability distribution of x because all the probabilities are positive, none of them is 0. So the first condition, that p of xi is positive or 0, is satisfied, and for the second condition we will add all the probabilities, 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8, which works out 8 by 8, which is 1. So the second condition is also satisfied, that summation p of xi is 1. In the next example, random variable x takes the values 0, 1, 2, and 3, and the corresponding probability mass function is defined in two ways. Number 1, p of x equals small x equals x minus 1 upon 2, and secondly, it is defined as p of x equals small x equals x plus 1 upon 3, and we have to tell which of them is correct. In the tabular form, it is random variable x whose values are 0, 1, 2, and 3, and the first probability mass function x minus 1 upon 2. Accordingly, the corresponding probabilities will be, for 0 it will be 0 minus 1 upon 2, that will be minus half. For 1, 1 minus 1, 0 upon 2, that will be 0. For 2, it will be 2 minus 1, that is 1 upon 2. And for 3, it will be 3 minus 1 upon 2, 2 upon 2, that is 1. For this probability mass function, one of the probabilities is negative. Hence, the condition that pxi should be positive or 0 for all values of I is not satisfied. Although the second condition, summation p of xi equals 1, is satisfied as sum of minus half, 0, plus half and 1 is 1 as required. So the function defined x minus 1 by 2 is not a probability distribution. For the second probability formula, x plus 1 by 3, we have for x equals 0, 0 plus 1 by 3, it will be 1 by 3. For x equals 1, it will be 1 by 1, 2 by 3. For x equals 2, it will be 2 plus 1, 3 by 3, which is 1. And for x equals 3, it will be 3 plus 1, 4 by 3. We observe that all four probabilities are positive. So the first condition that p of xi is positive or 0 is satisfied, and the second condition that summation of p of xi is 1 will be obviously greater than 1 because one of the values in the addition is 1. Hence the second condition is not satisfied. So the function x plus 1 by 3 is also not a probability distribution. We are given a probability distribution of random variable x and its corresponding probabilities. X equals small x. First, we have to find the probability that x is an odd number, which means p when x is odd, that will be p when x is 1, 3 and 5. That will be p x equals 1 plus p x equals 3 plus p x equals 5. It will be 1 by 36 plus 5 by 36 plus 9 by 36. That will be 15 by 36. 3 5s are 15, 3 1s are 3 2s are. So probability when x is odd will be 5 by 12. Secondly, we have to find p when x lies between 3 and 6, that is 3 less than or equal to x less than or equal to 6. That will be p when x is 3, 4, 5 and 6. That will be p x equals 3 plus p x equals 4 plus p x equals 5 plus p x equals 6. That will be 5 by 36 plus 7 by 36 plus 9 by 36 plus 11 by 36. That will be 32 by 36. 4 8s are 32, 4 9s are 36. So probability of x when it is between 3 and 6 is 8 by 9. The probability mass function of a random variable x is 0 except at the points x equals 0, 1 and 2. At these points, probability mass function has values p of 0 equals 3c cube, p of 1 4c minus 10c square, and p of 2 equals 5c minus 1. We have to find number 1 the value of c, number 2 p when x is less than 1, p when 1 is less than x is less than or equal to 2, and p when 0 is less than x less than or equal to 2. Now from the first condition of the probability distribution, we have summation pi equals 1, that is sum of all probabilities is 1. Therefore p of 0 plus p of 1 plus p of 2 equals 1. P of 0 is 3c cube plus p of 1 is 4c minus 10c square plus p of 2 is 5c minus 1, which is 1. This will be 3c cube minus 10c square plus 9c minus 2 equals 0. This is a cubic polynomial equation in C. From this constant term, we know that C plus minus 2 or C plus minus 1 could be its factors. By remainder theorem, if we put C equals 1 in this equation 1, then we get 3 minus 10 plus 9 minus 2, which is 0, and this implies that C minus 1 is a factor of this cubic polynomial. For finding remaining two factors, we will use synthetic division, in which we will put c minus 1 equals 0 to get c equals 1. So we write this 1, and the coefficient form of this cubic polynomial 3 minus 10 9 minus 2. We write this 3 directly here. Then 3 ones are is 3. Minus 10 plus 3 will be minus 7. Minus 7 into 1. Minus 7. 9 minus 7 is 2. 2 into 1 is 2. Minus 2 plus 2 will be 0. Now this 0 is remainder after this synthetic division, and this is the coefficient form of the quadratic polynomial 3c square minus 7c plus 2, which can be factorized by splitting the middle term 3c square minus 6c minus c plus 2. After grouping the terms 3c into c minus 2 minus 1 into c minus 2. So the factors will be 3c minus 1 and c minus 2. So factors of this cubic polynomial equation will be c minus 1 into c minus 2 into 3c minus 1 equals 0. That gives us three possible values of c. C equals 1, c equals 2, and c equals 1 by 3. So the value of c is 1 upon 3, and it cannot be 1 or 2 because probability cannot be greater than 1. After finding this c, we have to find p of x less than 1, which will be p of x equals 0. That will be this 3c cube, that is 3 into 1 by 3 cube, which will be 1 by 9. Now this p of 1 less than x less than or equal to 2 will be p of x equals 2, which will be nothing but this 5c minus 1, that will be 5 into 1 by 3 minus 1, 5 by 3 minus 1, which will be 2 by 3. And finally this p of 0 less than x less than or equal to 2 will be p of x equals 1 plus p of x equals 2, which is this 4c minus 10c square after putting c equals 1 by 3 square plus p of x equals 2. We have just found out 2 by 3. This calculation works out to be 8 by 9. A random variable x has following probability distribution. We have to find number 1 k, number 2 p of 1.5 less than x less than 4.5 upon x greater than 2, and thirdly the smallest value of lambda for which p of x greater than or equal to lambda is greater than half. For finding the value of k, we will use summation p of xi equals 1. So that will be adding all these values of probabilities. This will be 10k square plus 9k equals 1, which will be 10k square plus 9k minus 1 equals 0. This is a quadratic equation in k. Two factors of minus 10 will be 10 and minus 1. So by splitting this middle term, we write 10k square plus 10k minus k minus 1 equals 0. That will be 10k into k plus 1 minus 1 into k plus 1 equals 0. Two factors will be 10k minus 1 into k plus 1 equals 0. Equating each factor to 0, we get two values of k. the first being 1 by 10 and the second k equals minus 1. K being probability, it cannot be negative, so we cannot take k equals minus 1. So the correct value of k is 1 by 10. After substituting the value of k, the probability distribution of x will become, in the second question, we have to find p of 1.5 less than x less than 4.5 upon x greater than 2. Now this is a case of conditional probability p of a upon b, which means probability of a when b has already occurred, which equals probability of a intersection b upon probability of b. Accordingly, p of will become probability of 1.5 less than x less than 4.5 intersection x greater than 2 upon p of x greater than 2. This will be probability of 2 less than x less than 4.5 upon probability of x greater than 2. The numerator will include p of x equals this 3 and 4. P of x greater than 2 will include p of x equals 3, 4, 5, 6 and 7. P of x equals 3 and 4 will be 2 upon 10 plus 3 upon 10 upon 2 upon 10 plus 3 upon 10 plus 1 upon 100 plus 2 upon 100 plus 17 upon 100. This will be 5 upon 10 upon 5 upon 10, 20 upon 100 equals 5 upon 10 upon, after cancelling this 0, 7 upon 10, which finally will be 5 upon 7. So the probability of 1.5 less than x less than 4.5 when x greater than 2 has occurred will be 5 upon 7. In the third question, we have to find the smallest value of lambda for which p of x less than or equal to lambda is greater than half. From the table, probability of x less than or equal to 3 will be p of x equals 0 plus p of x equals 1 plus p of x equals 2 plus p of x equals 3, which is 0 plus 1 by 10 plus 2 by 10 plus 2 by 10. This will be 5 by 10, which is half. But we need p of x less than or equal to lambda greater than half. So in order to increase the value, we will add one more probability. Therefore, we will find p of x less than or equal to 4. That will be this half plus p of x equals 4, which is half plus 3 by 10, which will be 5 plus 3 by 10, 8 by 10, 4 by 5, which is greater than half, which implies this lambda should be this 4. Hence, lambda equals 4 is the answer. We are given this probability distribution and we are asked to find number 1, conditional probability of x less than 5 when 2 less than x less than or equal to 6 has already occurred, and second, conditional probability of x equals 4 when 3 less than or equal to x less than or equal to 5 has already occurred. In conditional probability of two events A and B, probability of A oblique B, that is probability of A when B has occurred, is probability of A intersection B upon probability of B. So accordingly, this first probability will be probability of x less than 5 intersection 2 less than x less than or equal to 6 upon P of 2 less than x less than or equal to 6. First we will check which numbers come under this part and this part. So x less than 5 will contain 1, 2, 3, 4 intersection. 2 less than x less than or equal to 6 will contain 3, 4, 5 and 6. In the denominator, 2 less than x less than or equal to 6 will contain 3, 4, 5 and 6. In the numerator, the intersection of these two sets will be 3 and 4. So it will be p of x equals 3 plus p of x equals 4. In the denominator, it will be the addition of these four probabilities, p of x equals 3 plus p of x equals 4. After substituting the values 3 by 8, 1 by 64 upon 3 by 8 plus 1 by 64 plus 9 by 64 plus 2 by 64. This will be 24 plus 1, 25 by 64 upon 25 by 64 plus 11 by 64. So that will be 25 by 64 multiplied by 64 upon 36. So probability of x less than 5 when 2 of x less than or equal to 6 has already occurred is 25 upon 36. Friends, if you like this video, please click the like button. Share this video with your classmates. Don't forget to subscribe this channel. Make constructive comments to help improve my videos. See you in the next video. Until then, keep watching Number Collage. Thank you.